rectangular box with these dimensions, and we're putting a metal cylinder inside the box. So I will attempt to draw a box that will help make sense of this drawing or this problem. That is certainly a fine box. So the dimensions don't look quite right for something being 8 feet tall, but we'll just go with this. So we'll go with 8, 4, and 5. We'll do that. It doesn't actually matter whether the picture matches. We're fitting a metal cylinder here so that it fits snugly into the box and stands upright. The issue here then is that the metal cylinder can only have a diameter of whichever side is the more narrow. So if the cylinder is standing in the middle of the box here, even though it's 5 units long, it can only be 4, have a diameter of 4. Likewise, a cylinder that's standing with this side as the base, it has 5 this way, 8 this way, but it only can have the well, it didn't come out right, but it would actually, the 5 would be the limiting thing, not the 8. Likewise, this one here with sides of 5 and 4, it would also have the 4 as the limiting reagent as if it were a chemical reaction. Anyway, so we need to figure out which one has the largest volume, and you can't tell just by looking in that, because even though one of these has a smaller radius, it's going to be going with the height of 8. So we need to actually make a chart. Remember the formula for the volume of a cylinder is the area of the base, pi r squared, times the height of the cylinder. So it may help to make a chart. In fact, I can't imagine doing this any other way. So we have one that is the 4 by 5 base. We have one that is the 4 by 8 base. And then we have one that's the 5 by 8 base, which means then that the height is the remaining dimension. So if it's 4 by 5 base, it has the height of 8. 4 by 8 base has the height of 5. And the 5 by 8 base has the height of 4. We can also then figure out the radius. Remember, the radius is going to be half the distance of the shorter of the two sides. So since the shorter side on this one is 4, the radius will be 2 of the cylinder. This one also will be 4. This one will be 2.5 because it's half of 5. So then we can figure out the pi r squared h for each of these. Pi r squared h for this one, 32 pi. For this one, 20 pi. And for this one, 25 pi. The one with the greatest possible volume is the one with the 4.5 base. And so the diameter is 4. Answer choice C.